Today we're going to be looking at enzymes. What are enzymes? Enzymes are proteins found in all living things that are responsible for making chemical reactions happen quicker. They are also called biological catalysts, which means they help to speed up chemical reactions without being used up themselves. They're usually a long string of amino acids. Remember, proteins are all long strings of amino acids that have curled up into a very specific shape. How we're going to symbolize that and show that in this video is using a bit of plasticine. I've got one enzyme there and one enzyme here. Okay. Now, enzymes are proteins and they have very specific shapes. And they do different things. And the big thing that enzymes could do is they could either break things down or put things together. So for example, this enzyme on the left here could be responsible for putting this bit and that bit together, and they connect it, and they release it as a product, all stuck together. Or they can take one of these bits as it fits into the enzyme and then breaks it apart into two separate things as the products. If we examine one enzyme in particular, we will see that, so this will be our enzyme. The groove that's sort of hold there is called the active site. The thing that fits into that groove, this thing before, which I showed you just now, is called the substrate. This one particular substrate has the right shape that fits into the enzyme. If we look back at the other enzyme from before, you will note that this enzyme does not fit that substrate, does not fit that enzyme. Therefore, that enzyme cannot work on that particular substrate. So we have the enzyme, we have the substrate. The substrate, like I said, fits into the active site in a perfect fit kind of way. Lock and key mechanism. This is like a key that unlocks this lock. Okay. So as it fits in, it can then be, the enzyme can then do its thing and then break this apart and release what are called products. From there. We now have to examine how to make an enzyme work faster or slower. So again, we have our enzyme. We then have all our substrates. Forgive the unevenness of the substrate. They should all really be the same size because they're the same molecule that goes into it. So we have all these substrates. We have one enzyme. How do you make the enzyme work faster? So first, before we do that, we have to keep in mind that an enzyme only works when it encounters the substrate, it hits the substrate at the right sort of angle, and the substrate goes bam perfectly inside the active site. This is called a successful collision. So, with that in mind, how do we make more successful collisions turn up? We can either increase the substrate concentration so that this one enzyme goes breaks this down, and eventually hits all of the substrate floating about. Fine. We can increase the substrate concentration. We can also increase the enzyme concentration. If we increase how many enzymes there are, the chance that that enzyme is going to meet that particular substrate is going to be greater by random. Remember, all this is random motion because particles are constantly moving all the time. Okay? Okay, next thing to look at is how temperature affects enzyme activity. Remember, everything here is constantly moving, and every enzyme has an optimum, so the best, optimum temperature. Now, what does this mean? This means that particles are constantly moving with kinetic energy, as you all know from physics. Okay, so they're always constantly moving around. These should be moving around, but they're a bit stuck. Okay. The greater the temperature, the greater the movement. The greater the movement, the more chance that these guys are going to hit these guys and have a successful collision. Ta-da! So the greater the temperature, the greater, I'm going to write this down because it's important. The greater the temperature, the greater the kinetic energy, the greater the chance of successful collisions. Of a successful, does this fit in the screen? Yes. However, if, however, the temperature gets too hot, what happens is the enzyme becomes denatured. As you can see, when an enzyme becomes denatured, the active site changes shape. When the active site changes shape, the substrate can no longer fit. Sad substrate. This is now a sad substrate. Ta-da! Every enzyme also has its own optimum pH. If, for example, this enzyme is what we call protease, and it works in the stomach, its optimum pH is going to be quite low, of around 2. At 2, the enzyme is shaped beautifully, the substrate fits beautifully, the enzyme can do its thing and break it down. If, however, the pH changes and then becomes 7 again, what happens to the enzyme? It gets denatured. Again, with denaturing, this active site changes shape. The substrate no longer fits. So the substrate again is unhappy days. Because it can't fit, it can't be broken down by the enzyme anymore.